The replacement of fossil fuels in our transport system can be done, as we have seen in the previous video, with the use of hydrogen as an energy carrier, but it can be also done by using alternative fuels. The good thing that these fuels have is that they can be used with small or zero changes in our current technology. So we can use it in our cars without changing so much our technology, and this is a very good thing of these alternative fuels. Okay, the main goal of this chapter is to know which are these the main alternatives that we have in these new fuels, and we will know which is the improvement that they can provide. Okay, the most extended of these alternative fuels is biofuels. The biofuels are fuels that are generated from natural crops or the waste of these natural crops. In order to be used as a fuel, we need to make some chemical changes in these molecules, but are similar, these changes, that the changes that has been done inside the earth when also has changed from natural molecules to hydrocarbons. So it is more or less the same, so making some changes in the natural molecules, but in our case, in the case of the biofuels, we will do it through the use of chemical reaction. So this technology is able to be used directly in our petrol stations because it does not need any change in our motor, and this, as I said, is a very good thing. Well, the good thing of the biofuel is not that it does not emit carbon dioxide when we burn it, because it's exactly the same as the fossil fuel, but that before using it, we are growing a crop that in fact is extracting carbon dioxide from the atmosphere. So if we see the complete cycle, the net increase or reduction of carbon dioxide in the atmosphere will be zero, because, as I said, before using it, we have removed it from the atmosphere. So this is the good thing. And we can do the biofuel by directly processing our crops, or by processing the waste that we have from crops that we use for meat. In this change, so in changing from fossil fuel to biofuel, the benefit is that we don't increase the carbon dioxide of our atmosphere. Well, but not always the situation is so good, because in some situations there can be increases in the carbon dioxide of the atmosphere, depending on the way that we process these crops, or the way that we grow it. Well, we have to think that if we replace a forest by a crop, when we burn the forest, we are previously removing a large amount of carbon that is stored in these trees and releasing into the atmosphere. So even if we don't burn it, if it's rotted, if we leave it and it's rotted, there will be also an emission of carbon dioxide that it's not, so it can cancel the benefit of the biofuel. The second question that we have to consider is that if we need a lot of machinery in order to grow our crops, this machinery will be also releasing carbon dioxide, and that will be reducing the net benefit of using a crop. So this is the second question that we have to consider. And the third important question is that in making a change of the land use, the abundance of carbon in the soil can also change, and this change can also be released into the atmosphere. So this is also a thing, so a question that we have to think about it just before using or generating biofuels. So depending on these situations, the benefit of the biofuel respect other fuels, like for example gasoline or natural gas or carbon, will be different. And in some cases, the biofuel can emit into the atmosphere more carbon dioxide than, for example, carbon. So just before just growing our crops to make biofuel, we need to think about all these things. Another question that we have to consider is that sometimes the land change is, for example, we can have a crop that we use for feeding, that we can change it and use it to, for example, for make some biofuel. And we can think that in this change we have not changed the land use. So it was a crop, now it is a crop, there is no problem in this. But the crop that we use for feeding should be replaced by another crop, and this crop can come from another region. And if in the region where they grow the new crop in order to provide us the feeding that we are not growing, maybe in that region they are changing the land use. So we have to think about all this in a global scale, because sometimes these lands changes are so indirect and we cannot trace it correctly. So it's not just start growing and growing new crops to make more biofuels, but we have to think which crops are replaced by other, or which forest has been removed in order to make this change. So when we consider the benefit of biofuels, we have to consider all these questions. Well, another benefit another technology that can increase the benefit of biofuels is the carbon capture, because sometimes just parallelly to using the natural growth of crops that are removing carbon dioxide, we can also use carbon capture to not to emit the carbon dioxide into the atmosphere. For example, transform it into a liquid and put it inside a mine or in the soil. So in doing this, we are increasing the benefit of using our biofuels. Well, let's go now for the second alternative fuel, that is ammonia. Ammonia is a molecule that is composed with 3 hydrogens and one nitrogen. It's very similar to methane, but replacing the carbon with the nitrogen. This molecule can be used to transport hydrogen, because if you remember, one of the worst things of hydrogen is that it was a gas, so we need to liquefy it. And if we combine it with nitrogen, naturally ammonia is a liquid. So it is a way to liquefy this hydrogen and transport it, and then use it as an energy source by removing the nitrogen and using once again the hydrogen. So we can also burn directly the ammonia, that it would be more or less the same, because When we burn ammonia, we combine the ammonia with the oxygen combines with the hydrogen, just in the same way as we saw in the hydrogen chapter, and nitrogen combines itself, generating a nitrogen molecule that is released to the atmosphere. Obviously, nitrogen is inert, so the 70% of our atmosphere is nitrogen, so there is no problem in releasing this molecule. And also generating water, it's also not harmful. So burning ammonia is a good alternative. The problem is that in burning ammonia we have right now several problems that we have to improve, so we have to correct. One is that ammonia needs a very high ignition temperature. Differently to fossil fuels can ignite at a very low temperature. Ammonia needs a very high temperature, and this is difficult to achieve in the internal combustion vehicles. The other thing is that it has a very low combustion rate. It's not so explosive as fossil fuels, so this is the other characteristic that is not good to be used in transport. And the third important con of using this technology is that it's not so clean as we have shown in the previous reaction. When we use it inside our motors, it can be also produce nitrous oxides and nitrogen oxides that are also greenhouse gases. So these are three undesired characteristics of burning the ammonia that right now there is a lot of research trying to improve these characteristics. Well, let's see energetically if it's a good, which is the difference between burning ammonia and burning methane. This can be observed in the energy that is stored in the different molecules. If we put the energy that the different molecules have, we have on the left side the molecules that get into our motor, and on the right side the molecules that goes out. And the difference in the energy between both sides is the amount of energy that we get. First of all, notice that all the energy are negative, that it means that the energy, the higher the value it is, and the more negative that will be, so it means the lower the energy that the molecule have. And the interesting thing is starting from a molecule with a high energy and ending with a molecule that it has a very low energy, and the difference is the amount of energy that we get. And you can observe here that the molecule that is playing the role is on the first place ammonia, and on the second place the water. And the difference between ammonia and water is the amount of energy that we get. Notice that in generating nitrogen, molecular nitrogen, we don't get energy, but on the contrary, the energy is increasing from negative value of ammonia to zero value of nitrogen. In the case of methane, we have a very different situation. In the case of methane, both molecules that get out of our motors are molecules that has a very low energy compared with the ones that has get into our motor. So this means that in generating carbon dioxide, we are obtaining so much energy, and also in obtaining the water. So the combination of these two reductions of energy is the reason why when we burn fossil fuels, we obtain so much energy. So The question is that with methane, the effect of the carbon that it's increasing the amount of energy that we get is not replaced by the same amount in the nitrogen case. So that's the reason why this technology is not expected to give so much or as much energy as the methane. But even in this case, there is a net extraction of energy. So at the end, maybe in some cases, like for example, in the maritime transport, it can be a good alternative. Well, in conclusion, the production of alternative fuels is an interesting option because it can be used in the existing internal combustion engines. On one side, biodiesel bases the improvement in the fact that we are removing the carbon dioxide before burning our fuel. And in the case of the ammonia, the good thing is that the molecule allows the transport of hydrogen without the use of the carbon atom.